All right, here's another Coulomb's law problem, conservation of charge. Charge is going to be conserved. We have three spheres. Sphere A, which has a charge of plus 6 coulombs. Sphere B, they're all supposed to be the same. I'm not drawing those circles right. Sphere B of minus 2 coulombs, and sphere C of plus 4 coulombs. Okay. Just keep this in mind. The net charge to start, 6 plus minus 2 is plus 4, plus 4. The Q net, Q is the symbol for charge, is plus 8 coulombs initially. At the end, if we don't have plus 8, we're in trouble. Charge is conserved. But here's what happens. Okay. A touches B, and then they are separated. So this one comes here, this one comes here. They touch for a moment. I don't know why that's not snapping to a circle, and that one snaps to a circle, maybe. Of course, you're supposed to touch, whatever. Who knows? Try that one more time. I don't want to spend all this. Whatever. They touch. A and B, they get touched. The charge will distribute themselves. In this case, the net charge of just A and B is plus 4. They're both, this one's really electron hungry. This one has some electrons to give, right? B has some electrons to give. A is electron hungry. That's how you spell hungry. And it's going to steal electrons, and it's going to make sure it's so much more hungry for electrons than B is, and B has some to give. What ends up happening is A will end up having a charge of positive 2 coulombs, and B is going to end up with a charge of plus 2 coulombs, because between these two, just these two guys, Q total is plus 4. That becomes plus 2 coulombs, plus 2 coulombs distributed evenly between the two. Now that's distributed evenly because they are identical. If one had a larger surface area than the other, the charge would not be distributed evenly. But that's not the case in this scenario. All right, so A touches B and then is separated. Now A is going to touch C. So we're going to take A and touch C. So A comes over here. Doesn't look like that. A comes over here, which has a charge of plus 2 coulombs, and touches C. Now the net charge of these two guys, the Q total for these two, is plus 6 coulombs. That plus 6 coulombs, they're both electron hungry. C is more electron hungry than A is, but it's gonna balance itself out, the electron hungry, the charge, and you're gonna end up with, when they're separated, C looks like that, and A, if this is plus 6, that plus 6 is going to separate themselves to plus 3 coulombs, plus 3 coulombs. It's going to divvy itself up evenly. All right, so A touches, that's supposed to be the letter B, and then it's separated. Then A touches C, and finally, what's last, now what's going to happen, B over here, which has a charge of plus 2, touches C. we're going to bring B as a charge of plus 2 coulombs over here. So now these two guys have a net charge. The Q there is 5 coulombs. They're going to separate. Again, the electron hunger between these two will distribute themselves evenly. And you'll end up with B, come on, snap into a circle. B and C plus 2.5 coulombs, C plus 2.5 coulombs, right? The 5 coulombs distributes itself evenly between those two guys, plus 2.5, plus 2.5. Now to double check, did we lose any charge? A plus 3 coulombs, B plus 2.5 coulombs, C plus 2.5 coulombs, A plus B, 5, 8, plus 8 coulombs. Q net charge is conserved. We didn't mess up. All is good. Again, the final results here. What is the charge on each sphere? A is going to have a positive 3 coulombs of charge. B will have positive 2.5 coulombs. C will have positive 2.5 coulombs.